I think this is quite a nice question here on waves. We're looking at just basic phenomena of waves and talking about the frequency and amplitude which we use to describe waves. Press pause, try the question, and then we'll have a look at the answer. So like I say, I would say this is one of these questions which is quite a nice one, and if you've done, for example, GCSE physics, you'd probably be okay with this as well, but let's talk about it as well. We're looking here at the amplitude and the frequency. Now the first thing I would do here is remind myself of what amplitude means. Amplitude is something I can get directly from the graph. Our amplitude is simply the distance from that undisturbed point to the maximum displacement. So you can see here we've got 0 to 5. This 5 is in nanometers. We're looking for an amplitude of 5 nanometers. Okay, why have they put 10 in here? Well, a lot of people think that it's the distance from the crest to the trough. It is not. It's from the center undisturbed line, and so therefore our amplitude is here. It means we can immediately rule out C and D. What a nice question. We can, just by no calculation, simply rule it out. Now the question then is, how do we calculate frequency? Frequency is a little bit harder. However, we should be aware, firstly, that it's related to the period of the wave. The period of the wave is shown here by this red arrow here. Okay, this is T. And you can see there we're going from 0 all the way over to 4 milliseconds. Okay, which means 4 times 10 to the minus 3 seconds. We're going to calculate F equal to 1 over T, which is going to be 1 over 4 times 10 to the minus 3, which is 1 over 4 times 10 to the 3, which is 250, which is why our answer here is B. As I say, really nice question, this one, especially if you've been struggling through a few of them. It's one where you can gain a bit of time on your paper 1A, you can get that right, feel confident about it, and then move on to use that spare time perhaps to do some harder questions.